So the QMA and GM thing. Yeah, okay, so f of x is a function that works. Yeah, f of x equals x definitely works because it does. I'm really liking this paper so far. Like, yeah. Um. Okay. I mean like the okay x squared plus f of y squared over two is always going to be bigger than or equal to x f of y because if you multiply across by two and move the this thing to this side, you're going to get the x minus fy squared is bigger than zero, which is always true. So the the thing on the left is always bigger than the thing on the right, regardless of the function or like regardless of anything, just for any real numbers. So okay, one nice thing we can do, like I haven't done much stuff with functional inequalities, but one thing I remember is if you can force the if you can bound something from the top and from the bottom by the same quantity, then you force equality, right? If you have x bigger than a and less than a, that means x has to be a, right? So okay, can I get the x f of y equals x squared plus f of y squared over 2? Well, yeah, I can because I can pick x equals fy. Like because if you like because this is equivalent to x minus fy squared is bigger than 0 or like equals 0. So if I sub x equals fy, I get that root fy squared, so just fy. So f of y is greater than or equal to f of y plus y over 2, which is greater than or equal to f of y. Okay, so we have that f of y plus y equals 2f of y. And okay, this is okay. If this were integers to integers, we could solve this like straight away. But it's positive real. Okay, so the good thing about positive real numbers is like any inequality holds. Yeah, but something like AMGM doesn't hold if you take negative numbers. Okay, so we have like f of y. Like this is kind of a nicer way to write it. Like f of y minus f of y is f of y minus y. Okay, so if you define like f of n of x and like the as the n's is like f applied n times 2x. So then we have that f of nx minus f of n minus 1x is f of n minus 1x minus f of n minus 2x. Yeah. Okay, wait. If we say this is like, I think this is, yeah. Because if I say like, it's like f of x minus x is g of x, then like, oh, okay, it's like x f of x. Like this is the rule for an arithmetic progression. So if you have f of x, x f of x, f two iterations x, that's an arithmetic progression. And the thing is that you have x plus n minus 1 times the common difference, which is g of x. So we have this thing. Okay. Okay. Wait, but if I hold on, if I plug n as 1, we get f of x equals x. Wait, this has got to be like this has got to be something wrong. Um Yeah. Maybe it's plus ng? I think it's plus n. Yeah, because f1 of x is the second term. So yeah, fine. Yeah, so the nth, I don't know if this helps or not, because I don't particularly want to plug like f of x into that thing. Because, yeah, just like an initial observation, we can say it's f of nx is x plus n dx, where g of x is f of x minus x. Okay, is this thing zero always? Because then we'd be done. If we consider g of x is zero, then we're done. Hmm. Okay, wait. What if like I mean given that f of x minus x kind of just came out of nowhere, maybe this quantity is some nice function. Maybe like g of x has to be some sort of nice function. Because it's literally like it's come out of nowhere. Like yeah, it's kind of like it's just emerged from the problem statement without me really doing anything. Like I just forced equality on the top and bottom, and this function g of x just springs out of nowhere. So this function should be something like related to it should be something nice. It should be something that is related to the problem in some way. I don't know. That might just be like that might not make any sense, but I feel like g of x must be crucial to the problem in some way. Yeah. So okay, what if I rewrite the whole thing in terms of g of x, and then try and show that g of x has to be zero? No, but then if I write the whole thing in terms of g of x, what I don't know is that g of x is positive for all x. I don't know that because f of x can be positive for all x, but we don't know that f of x is bigger than x for all x. Yeah. Oh no, but no, surely, no, but surely g of x has to be bigger than x. Sorry, surely g of x has to be bigger than zero. Because if g of x is less than zero, and f n of x always needs to be bigger than zero, right, for any n. But if g of x is less than zero for some x, then I can just make n very big, and then n g of x is going to become, and then x plus n g of x is going to become less than zero. Yeah. Okay, so okay, I think that's quite significant, right? Like f of x is greater than or equal to x. That's that's some progress. That's at least that's some partials. That's got to be at least one mark. Yeah, I think that's a mark. Okay. Yeah, because like we need to understand this function better. Because if I can show that f of x is less than or equal to x, then we're done. Yeah. Hmm. Okay, but what if there are other functions other than f of x equals x that work? I mean, like f of x equals x obviously works. But what if there's some other like random function that works? What if like I don't know, like 1 over x works? Does 1 over x work? Let's see. Okay, so if I put 1 over x, what happens? So x squared plus 1 over y squared over 2 greater than or equal to 1 over x plus y over 2 greater than or equals to root x y. Okay, is this thing true for all x and y? 1 over x plus y greater than or equal to 2 root x over y squared. Um, hmm. Is this true for? Oh no, wait. Okay. So I was thinking if you put x to 0, but then it's it's positive reals. It's a positive real, so 0 is not allowed anyway. I feel like if y is very if y is very small, then this side is gonna be bigger than this side. If y is small, you have y in the denominator here and y in the numerator here. So if you make y small, this one is going to blow up and this one's going to go down. So yeah, it's not going to be true. Okay. So like the function should grow roughly like x does. Yeah. Or it should grow like it should grow with degree 1. So it should be linear. Yeah, I mean like yeah, it should be linear. Like even this thing is linear. Yeah, because we got a okay, so I think maybe it's all linear functions. So if x is linear, what do we have? Does it hold for all linear functions? We have ax squared plus 2abx plus b squared over 2 greater than or equal to ax. By the way, no, it's f of y squared. My bad. Okay, so x squared plus a squared y squared plus 2aby plus b squared over 2 greater than or equal to ax plus b plus y over 2 greater than or equal to square root x ay plus b. Okay. Um. Okay. Let's try to remember what I had. So I had like ax plus b plus y over 2 greater than or equal to x times ay plus b. Then we can move 2 here in squares. We get a squared x squared plus b squared plus y squared plus 2abx plus 2axy plus 2by greater than or equal to 4xay plus b. So I guess this works in the same way as functional equations. So like the coefficients, you're gonna compare coefficients in the same way. At least you probably can. 4axy plus 4bx. Okay, maybe not. Okay. Okay, so I can get rid of this and make this a minus 2. So I can say it's ax minus y squared. So I take this one, this y, and this one. And then plus b squared plus y squared plus 2abx plus 2by minus 4bx greater than or equal to 0. Um, yeah, okay, so okay, if a and b are both 1, this is true. Okay, I can write it. Okay, so ax minus y squared, and then we have a b plus y squared as well, and then 2b 2 abx minus 4bx. So you have ax minus y squared plus b plus y squared plus 2bx. A minus 2 bigger than 0. So if I were to, oh, I can't put y as minus b though. Yeah, okay, b has to be positive, right? Yeah, b has to be positive because if f of x is ax plus b, and either one of them are negative, then if b is negative, I can make x very, very small, and then this thing will be negative, which is not allowed. So, okay. Yeah, I think this is, yeah, okay. I think it's quite hard for me to see functions that aren't linear working. Yeah, I really doubt that something like x squared is going to work here. Or like we tried one over x doesn't work because one side was going to grow faster than the other one. So, well, it grow at a different rate to the other one. I mean, um, okay, like if we assume f is a polynomial, let's say it has degree k. I know this is not allowed at all in these functions, but you can't just assume it's polynomial, but like just to get an idea of what polynomials would work as a function f, let's consider a special case of f as a polynomial. So if it has degree k, then the degree of the thing squared is going to be 2k. And we take the square root. Actually, no, yeah, you'll find. In terms of degrees, you'll find. Yeah, you don't find if it's negative, because then yeah, you don't find if it's negative. Yeah, so would something like x squared work? I mean, like, okay, let's try x squared. So x squared plus y to the 4 over 2 square rooted, greater than equal to x squared plus y over 2 greater than equal to xy squared. Okay. Oh, I see the problem. So the problem here is that wait, I had it. Yes, okay, so you have that f of x, um okay. Okay, so in this inequality at least, if you have x squared plus y greater than or equal to 2 root x y squared, you can pick y as say 1. No, y equals 1, this thing works. But you can make root x bigger than, I have to be careful here. Root x bigger than x squared. Can I do that? If I divide by root x, I get 1 bigger than x to the 3 over 2. So I get the square root of x cubed less than 1. Yeah, so if x is less than 1, this is going to be true, yeah. So if I make x a lot less than 1, yeah, if I make x a lot less than 1, and yeah, if I make x a lot less than 1, then root x is going to be a lot more than x squared. Yeah, I know it's kind of counterintuitive, but like half squared is a quarter, right? So a root of a quarter is going to be bigger than a quarter. Yeah, so if I make x very, very small, then 2 root x is going to be a lot bigger than x squared, and so this side is going to blow up faster than this side. Yeah, so x squared probably isn't going to work. Wait, but surely by the same argument, if I had x plus y greater than equal to 2 root xy. I could make the same argument and say if x gets very, very small, if x gets very small, root x is going to get a lot bigger than x, and then you lose. Why can I make that? Why does that argument work here and not here? Maybe it doesn't work for either, but it definitely doesn't work for this. So, yeah. Um, I feel like guessing the answer is a big part of this sort of question. Yeah, I think we need to get the answer. I mean, okay, let's actually for this inequality. I don't know if you can see it properly, but for can I see it properly? Yeah, I can see it. Okay, so if you if we actually plug a number, let's say we plug 1/10. If we plug 1/10, so let's plug like something with a square root that I know. So we have x squared plus y greater than equal to 2 root xy squared. Yeah, okay. If I plug x as 1 over 2, if I want 1 over 4 to the k, then root x is going to be 1 over 2 to the k. So I'm going to have 1 over 16 to the k plus y is greater than equal to 2 times 1 over 2 to the k y. Oh yeah, this is fine though. Yeah, this is fine. Because like, yeah, this is fine. Okay, wait. I mean like, here if 2 root x is less than 1, then you obviously win. So let's say 2 root x minus 1 is positive. So we have that y is less than or equal to x squared over, okay, 2 root x minus 1. But I can make root x very close to 1/2. Well, no, I don't want that. Yeah, okay, let's look at this function, x squared, 2 root x minus 1. Okay, let's say, rather than looking at x, let's go root x, because they have the same domain, right? So, yeah, I can plug positive reals into x, I can plug positive reals into root x as well. So, yeah, so then x is y squared, so y to the 4 over 2y minus 1. Um, I want to have this thing in the denominator, so that's like z is 2y minus 1. Uh, y is z plus 1 over 2. So z plus 1 over 2 to the 4 over z. This is z plus 1 to the 4 over 2 to the 4z. Okay, which is 1 over 16 times z plus 1 to the 4 over z. Okay. Okay. Now, can I make that thing very small? Can I make it very small? So I can make that arbitrarily small. Wait, no, wait. What am I doing? Obviously, this doesn't hold for all x and y, right? Because I can just make y very big. Yeah. Oh, yeah. Yeah. Fine. Yeah, you can just, whatever, you plug x, you get whatever, you get the function is whatever, you just pick y as more than that. Yeah, so yeah, this is not going to hold for all x and y. But why didn't it hold for all x and y? What's the actual reason? Like, well, Because okay, let's try f of x as x to the k equals some k. Okay, so x to the k plus y over 2 greater than or equal to root x y to the k, which is x y to the k over 2, which is x to the k plus y greater than or equal to 2 x y to the k over 2. Oh no, you have a root x here. Yeah, fine. Yeah, yeah. This is not not that easy. Okay. Like, what if I make y massive? Yeah, okay, no, but okay, so let's say that k over 2 is strictly bigger than 1. Then if I fix x and make y massive, yeah, if I fix x and make y massive, then, yeah, then this is going to outgrow this. Because we're fixing x, right? So this thing isn't going to move. And then I make y really, really big. And then this thing is going to overtake this. Okay, so, yeah. I think this is like a normal. Yeah, I feel like this might be found easier than problem 2. That's my, yeah. My instinct, yeah, I feel like this is going to be found. This is going to have more solved than problem 2 for sure. Because I guess people are more comfortable with algebra than geometry, but also I feel like this is a less difficult problem. At least, yeah, at first. I don't know, reading the solution for P2 doesn't look that bad, but like, I think a lot of the things are hard to come up with, but short to write down. That's the thing about P. I think it's hard to come up with, but short to write down. Maybe maybe it was just hard to come up with for me because I haven't done much geometry recently. But yeah, I think in general P2 is going to be found hard. That's my feeling. Oh, okay. So yeah, oh no, but this thing has to hold for all x and y. Yeah, so if I make yeah, if I make x very, very small and y very, very big, regardless actually no, not y very big. If I make x very, very small, and let's say k is positive. If k is positive and non-zero, and I make x very, very small, and I keep y the same. This is what I tried before, but it didn't really work. So if I take x as 1 over 2 to the m for some or 2m for a very big m, then I feel like this should work. So to the 2mk greater than or equal to 2 times 1 over 2 to the m y to the k over 2 minus y. So 1 over 2 k greater than or equal to 1 over 2 to the m minus 1 y to the k over 2 minus y. And then if I make m very, very big, then this is gonna become and k is bigger than 1. Yes, if k is bigger than 1 and I make m very, very big, this is going to grow. This is going to get small faster than this is going to get small. Yeah, because you can think of it as 2m to the power of 2k, and 2k is bigger than 1. Okay, so even k bigger than a half, even k bigger than a half, so you fix y, you put x as 1 over 2 to 2, and you make m massive. If k is bigger than a half, then 2k is bigger than 1. So 2 to the m to the 2k is going to grow faster than a half 2 to the m. And so this is going to be much, much bigger than this. And so if you take the reciprocal, this is going to be much, much less than this. And like whatever you had y as. Like if you pick y so that this, if you pick y so this is positive to start with, then you'll find. Okay, I feel like this is quite a convoluted argument. Like this is going to be very hard to make rigorous for an arbitrary function. Yeah. Okay. What if we can show if that x is strictly increasing or strictly decreasing? That would be good. Yeah, because then I can make arguments like this. So if x is strictly increasing, I can make arguments like if x grows, then f of x is going to grow as well, and then that's good. So yeah, and like we kind of have like we have f of x, like at least if you compare the middle and the right one, we have f of x, and then we have x on the other side. So like yeah, I think that we can do this. Okay, so let's transfer f is increasing. So let's say f of x is bigger than f of y, but x is less than y. Well, I mean, in a normal functional equation, if I showed it's increasing, that means it's injected, which is useful. But I don't think it's gonna be useful here. Yeah, but increasing that's gonna be useful because we have inequalities. So and we have that f of x is at least x. Yeah, that could be useful as well. Okay. So let's compare the left and the middle one. So the root of x squared plus f of y squared over 2 is going to be less than the square root of x squared plus f of x squared over 2, because f of x is bigger than y, and then f of y. And this is greater than or equal to f of x plus y over 2, when y is bigger than x. No, but then f of x is bigger than f of y, so something bigger than y plus f of y over 2. But I'm saying y is bigger than x, this is going to be bigger than x plus f of y over 2. Okay, yeah, I don't feel like this is going to be true. Yeah, I don't feel like this is going to work. So let's square it. So x squared plus f of x squared over 2 greater than x squared plus 2x f of y. plus f of y squared over 4. Okay, multiply by 4. So this thing's gonna double and this is gonna stay the same. So 2x squared f of x, 2f of x. It's kind of annoying when you run out of paper, okay? Um, let's do the whole thing again, but with more paper. Yeah. So like starting from the top of the page, so I can. Okay, so let's say f of x is bigger than f of y, and x is less than y. And I can swap x and y in the inequality thing. Yeah, I can swap x and y in the inequality thing, so that could be useful. So we have that root x squared plus f of x squared over 2 is greater than uh, y plus f of y over 2. I think let's keep it like this. So we have x and y equally as important. So square it, move stuff around, and then oh, okay. And now we use the fact that y is bigger than x, and yeah, that y is bigger than x. So this 2x squared I can replace with 2y squared because that makes the thing bigger. And anything with y I can replace with x because it's going to make it smaller. Oh, but does that really help? I think let's keep it as y here because I can cancel y squared. Yeah, but yeah, this is kind of hard. Like this is kind of a standard thing. Like even in functional equations, this is a standard thing that you want to show like increasing, and especially if you have something like this. Like it should be increasing. Like I think it's very unlikely that this is not increasing. I mean, okay, I think I have an idea. So f of x plus y over 2 is greater than or equal to root x f of y, which is greater than or equal to root xy. So then, but I don't have an f of x f of y. Yeah. Okay, maybe I use the fact that x is less than equal to. Yes, I'll say that root x squared plus f of y squared over 2 is less than equal to square root of f of x squared plus f of y squared over 2, which is greater than or equal to f of x plus y over 2. And then we're saying that f of x is bigger than f of y, so this thing is going to be, sorry, this thing. Can I see that? Yeah, it says f of x squared plus f of y squared over 2. That's going to be less than f of x. Because you replace the f of y with f of x, making the thing bigger. And so the thing becomes f of x. So f of x is bigger than f of x plus y over 2 for all y. This seems very unlikely. So a 2f of x is bigger than f of x plus y. So f of x is bigger than y for all, not for all y, but for all y bigger than x. That seems fine. For all y bigger than x. Oh no, but that can't be fine. That can't be fine because f of x is bigger than x. So I can take y and say f of x was 1, and it's not going to work. Okay, no, but I've shown it's increasing for specific y bigger than x, but I'm sure it's increasing for all y bigger than x. Yeah, I've shown. Okay, so what I've shown is if y is bigger than f of x. Yeah, so if y is bigger than f of x, then f of y is bigger than f of x. I feel like we can do better. I feel like we can do better. Yeah. Okay. I feel like we can definitely do better. Yeah. Yeah, I think this looks I think for someone with a lot of practice, this is not very difficult. Because I mean, there's nothing non-standard about this problem. Like, I mean, problem one, I think none of the problems so far have been non-standard, so to speak. Like, yeah, I feel like all the problems are quite, even like problem six, it looks like a standard problem. Like, I think something like problem five last year is quite non-standard. And yeah, something like 2024 problem five, that's obviously quite non-standard. Like, yeah, yeah. So I think this is a very trainable problem. That's what it feels like. Okay. So, yeah, what do we know about this function? You know the f of x is bigger than x, and our like intuition is saying f should be linear. Like it should be linear and is bigger than x. Hold on, if it's linear and it's bigger than x, then f of x is ax plus b. That's bigger than x. So a minus 1x plus b needs to be bigger than 0 all the time. So a needs to be bigger than 1. Okay, yeah. So it's less than 1, you make x very big, and then this isn't true. So a should be bigger than 1. Trying to get some sort of intuition as to what a and b should be. Okay, I mean like okay, a equals 1 definitely works because then we know that b is bigger than 0. Actually, yeah, it does. Okay, okay, can we prove that functions f of x is x plus b? Can we prove that they always work? Okay, let's plug that in and see what happens. Can we force b equals 0? Uh, y. This one, and let's square There's nothing really to talk about while doing this. Um, okay, and this is x minus y minus b all squared. Yeah, yeah, it is. Okay. Yeah, okay, this works. Fine. At least, no, for that side. Which side was this? This one is L bigger than, left bigger than medium. So let's go M bigger than R. Like, square again, so x plus y. X squared plus y squared plus b squared. Wait, you're gonna get the same thing. Yeah. You're getting exactly the same thing. Fine. Are you? Not, maybe not exactly the same thing. Yeah, because you have plus 2bx. No, no, no. I think, yeah, no, it's exactly the same thing. Fine. Okay. Yeah. Because actually, yeah, those functions always work. The fact this was x always works. Does, okay, what do I, let's try simple. Let's try like fx is 2x. Does that always work? Yeah, let's try and show this works. X squared plus 4y squared over 2. We know this bigger than this always holds, so let's square this thing. So 4x squared plus 4xy plus y squared will equal to, so 8xy. So 4x squared minus 4xy plus y squared is bigger than 0, and that's true, because 2x minus y all squared. Actually, I could have just seen that it's just AMGM on these, on 2x and y. Yeah. Yeah, it's just AMGM on 2x and y, fine. But that's nothing to do with any I don't think that's because of it. Like, that'll be true if fx is cx for any c. Um, maybe, yeah, maybe fx equals cx always works. Okay, let's square this one. So double this one, keep this one the same. Uh, so we have 2x squared plus 4xy minus 7y squared less than equal to 0. Can I like complete the square or something? Like I can say it's 2x squared plus 4xy plus 2y squared minus 9y squared less than 0. Then this is twice x plus y all squared minus 9y squared is less than 0. So we're saying that 2x plus y squared is going to be less than 9y squared always for all x and y. I doubt that's true. Because you can just make x very big, right? Yeah. You can just make x very big. Okay, so so yes. Okay, so we need to show that f of x minus x is a constant. Yeah, okay. Yeah, we need to yeah, f of x minus x should be a constant. Okay, so our intuition from before was right. The function g of x, f of x minus x, should be a constant. Like, I was thinking maybe it could be like, I was thinking maybe it could be some. I mean, I thought it should be something nice, something relevant to the problem. I thought it should be. I thought it should be 0, but it turns out it can be a constant as well. Yeah, because it definitely can't be a polynomial of some other degree. Yeah. Oh, no, but what if something like okay, no. What if something like yeah, what if something like f of x equals 2x plus 2 works? What if something like that works? Then yeah, what if it's some linear multiple of x plus b? Yeah. Okay, wait, yeah. So if f of x works, does c times f of x works as a function? That's yeah. Oh, okay. So if f of x is a valid function, and if like h of x is some constant times f of x, does that work as a function? Well, okay, so f of x will be some different constant times h of x. Yeah, and then uh, no, this should be y. Yeah, okay. So given that this is true, is can this be true as well? Yeah. I mean, I don't think it's obvious. I don't think it's obvious. Yeah, I don't think this is going to be true. Yeah, I don't think this shift works. Yeah. Uh, yeah. I don't feel like mm, yeah, okay. I don't feel like this okay, so, like this problem is about the thing, the QM AM GM.
Means.
So it's about it's about linear shifts. It's not about scalar shifts, it's about linear shifts. Because that's what that's what these are about, right? They're about like it's about averages, not like it was if it was something like fractions, like if it was something like xf of y over 7 is greater than equal to um yf of x times um f of y over 2 to the power of 28, something like some random like this, where you have stuff multiplied together, then scalar shift would make more sense, right? But here it's all about like linear shifts. Look at you have an xf of y, so maybe, but I think more like the left one bigger than the medium one. I don't think that's gonna respond well to scalar shifts. Like by multiplying my scales, but it will respond well to linear shifts. Yeah, okay. Okay, so what stuff do we know about this function? Did we show it's increasing? Maybe. I don't think we did actually. Yes, okay, so yeah, we wrote here. F of x is bigger than x, f should be linear. And we had from before, like f n of x. We're gonna bring back g of x. Yeah. Because we know g of x should be constant. I mean, yeah, and f of x bigger than x comes from this. Yeah, because g of x is f of x minus x. So this, I think this is gonna be core to the problem in some way. Okay, so what if we plug what if we plug like f of x for x instead? Like that could give us something good. So let's think. So what I was thinking for f of x was like where this whole stuff with g came from originally. It was f of x minus f of x is f of x minus x. That's where this whole stuff with g came from. So okay. Okay, so if we fix x, g of x is constant, right? Because you're not moving x, so you're not moving g of x. We want to show that g of x is constant across all x. Maybe we do like a similar trick that we did in what was the thing? Like yeah, in IMO 224p6 there's a trick like it was something like f of r plus f of minus r. And then the trick was you assume it's equal to two different things, and then you find out some stuff about those two things. Yeah, you show like yeah, I think it's possible to show like if you have if there's two things, one of the things must be zero. Yeah, so with this g of x, let's say for two different x and y, what if g of x is different to g of y? And then we plug some stuff and see what happens. I think yeah, because it's not gonna be like yeah, it should be f of x is x plus b for all x. It shouldn't be like it's x plus one for even x and x plus two for odd x or something like that. Like it should be the same constant for each x. Yeah. Okay, so you still it's a long you get a long time in IMO to think about stuff like this. Okay, so what was our idea? It was like yeah, so what if g of x can be two different things and then do some stuff? But is this a good idea? Can this work? Okay, g of x is definitely relevant to the question. Okay, what if I rewrite this? What if I rewrite this fn of x in terms of g of x? Okay, so if I say f of x is x plus g of x, okay, then f of x is f of x plus g of x, which is g of x plus g of x plus x plus g of x. And 2f of x minus x is 2x plus 2g of x minus x, which is x plus 2g of x. And these two are equal. So we have g of x is g of x plus g of x. Okay. But maybe we can just get g constant from this. No, probably not. Okay, so what if so we have, yeah, I think this is similar to, this is giving like, IMO 2, like 2023 question 2, similar to the thing. Like, g of x is g of f of x. And I can put x as f of x. So we say g of f of x is g of f of 2 of x. Yeah, so we can get a lot of inputs giving the same output for g, right? Because like x, but yeah, okay, so you have the g of x equals g of fn of x for any n. And fn of x from this thing, so we have g of x is g of x plus ng of x. Okay, yes, we can shift by g of x anywhere. Okay, yeah, so this very strongly suggests that g is constant. Like, yeah, but can we force g is constant from here? I don't think we can force it. Yeah, I think we need a few more conditions on G. Yeah, because this thing only involves X. It doesn't involve anything else. So no, like if X was 7 and v of 7 is 1, then you know everything about G of an integer, but you don't know anything about G of different stuff. So you know about G of X. You know G of X when you change X by shifts of G of X, but you don't know about the stuff in between. Yeah. So okay. Oh, okay. I don't think we've actually proved very much. I think we've had a lot of good thoughts and a lot of good thinking, a lot of good intuition about what the function should be. We haven't actually done very much. What have we even done? We've got fx is bigger than x, and we got this thing, but that's about it. Yeah, we've got to actually impose some conditions on it. If we're going to find Yeah, if we got to actually get some more conditions about it. Like, okay, so if f of x is x plus b, f of x should be increasing. So let's actually try and show f is increasing. Okay, yeah, let's do that. So Okay, f of x is bigger than f of y, and y is bigger than x. Okay, and then we know like f of y is bigger than or equal to y, which is bigger than x. Okay, so we have this chain. Yes, f of x is bigger than f of y, which is bigger than or equal to y, which is bigger than x. Okay, is this possible? Okay, so let's say you have numbers like a bigger than b, bigger than c, bigger than d, and we're saying that a plus c over 2 is bigger than or equal to root bd, and it's going to be less than or equal to root b squared plus d squared over 2. And is the biggest one. Well, I think, yeah, I think this one looks very suspicious, right? Because, I mean, root of b squared plus d squared over 2 is going to be roughly b plus d over 2, which is going to be less than a plus c over 2. Yeah, I think that this one is quite suspicious. Um, so if we square and move some stuff, we should get a contradiction from this. Yeah, okay, so yeah, I think we're done. So with the increasing, so we have a squared. Okay, so we have a squared plus 2ac plus c squared minus 2b squared minus 2d squared. Okay, so, oh no, we might not be done actually. Yeah, because I was thinking like, okay, we got four things here: a squared, a plus a squared, ac, ac, c squared. And here we got b squared, b squared, d squared, d squared. And these guys are gonna take these guys, right? Because like from bigger. But the thing is, a squared takes b squared, but then ac doesn't necessarily take b squared. Yeah, like yeah, ac takes d squared, and c squared takes d squared. But this one might not be true because yeah. Okay. Yeah. Okay, but I feel like even if this method doesn't work, I still feel like this shouldn't be true. Okay. But let's try and find numbers A, B, C, D, positive real numbers so that this thing is false. Yeah, like come on, like no way. Like how can this be true? Like come on, like 2b squared plus 2d squared is bigger than a squared plus 2ac plus c squared. A is bigger than b, c is bigger than d. Like Like, I don't like. There's no way this can be true. No, wait. If all of them are equal, it's true, but they're not all equal. Yeah. Okay, I feel like this is a very bad way to do this, but if we do C is B plus X, B is B plus X plus Y, and A is B plus X plus Y plus Z, and we know that X is bigger than 0, Y is at least 0, and Z is bigger than 0. And we just expand everything. We're gonna get a bunch of stuff cancel, and then we should be left with some combination of these. Yeah, that doesn't work. Okay. Yeah, I mean, we have nothing better to do, so let's try that. B plus X plus Y squared plus 2D squared greater than equal to D plus X plus Y plus Z squared plus 2D plus X plus Y plus Z D plus X plus D plus X squared. Oh, no, this doesn't look fun to expand at all. Because you have like D plus X plus Z squared. So you have so many like 2dx, 2dy, 2dz. This might be beyond my skill level right now. It might be. Unless we can find a good idea. But we're gonna keep trying until the end. Okay, we don't know very much, do we? We just know this. That's the only thing you can actually prove about this. And I'll guess that the G should be constant. Okay, let's actually try it. We don't have to increase, but let's try the idea that we had. Like, let's say that it's x plus NA, and then let's do something like this. And B and A and B are different. And then let's like, yeah, let's plug Y as FMX or something. Okay, let's plug X as FMX and let's plug Y as FMX. Okay, so FMX is nothing but X plus M, and FNX is FNY is nothing but okay, we're saying this is Y and this is Y. So we're saying like Fn of Y is nothing but Y plus NB. And then we're gonna get F of Fnx, which is F of M plus 1x, which is gonna be X plus M plus 1a. And then F of N plus 1 Y is Y plus N plus 1b. Okay, so let's do it. So we get X plus Na squared plus y plus n plus 1b squared over 2 greater than or equal to x plus ma plus, oh no, it's f of x, so this one's n plus 1a plus y plus nb over 2 greater than or equal to root x, no x, it's fmx, so x plus ma y plus n plus 1, n plus 1 b. Okay. No, but squaring this thing looks so bad. Yeah, this looks so bad. Um, actually, no, I can keep it as like, I can say it's x plus ma plus y plus nb. I can say it's x plus ma plus y plus n plus 1b plus b minus a. Yeah, I think let's do that. So let's square it, but let's square it like that. So we're gonna get x plus ma squared, and then we're gonna have to double this stuff, right? We've done this stuff, so we double the numerator of this thing, y plus n plus 1b squared, greater than or equal to x plus ma squared plus y plus n plus 1b squared plus b minus a squared plus like a bunch of other stuff, right? Plus like 2x plus ma b minus a plus 2 y plus n plus 1b b minus a plus 2 x plus ma y plus n plus 1b. Okay, we can like cut this and then because our goal is to force b equals a. Yeah, this is too much algebra. Yeah. Okay, let's write this inequality and let's look at m bigger than, let's look at the middle one bigger than the right. Let's look at that. So let's keep this one, let's write this one at the top. Maybe like the combination will imply a equals b. Okay, and then like the other one is, what's that gonna be? That's gonna be, let's write it in the same way. So let's say, let's write the middle one in the same way. So let's say it's x plus ma plus y plus n plus 1b plus b minus a. Yeah. over 2, which is greater than equal to, um, wait, no, but yeah, let's just write, okay, let's say like x plus ma is c, y plus n plus 1, d is b. And then that makes everything like, yeah, okay, so let's do that. So we have c squared plus d squared. And let's say b minus a is like x. So c squared plus d squared is bigger than x squared plus 2cx plus 2dx, no, yeah, 2dx plus 2cd. And this one is c plus d plus x over 2 greater than or equal to the square root of cd. And our hope is that these two together are going to imply x is 0. And okay, this one, this one only really implies, because this one rearranges to root c minus root d squared plus x is bigger than 0. That just tells us x is bigger than 0. Like, it can't tell us anything else. So yeah, b is bigger than a, fine. X is bigger than 0. And moreover, it's not just bigger than 0, it's bigger than the, this thing. It's bigger than, actually, it need not be bigger than 0. It could be less than 0, but it's just bigger than, it's just bigger than this. Yeah, it's just bigger than this thing. And now we want to like complete the square. So we can say x squared plus 2cx plus 2dx. This thing is x squared plus 2c plus dx, which is x plus c plus d squared minus c plus d squared. So it's c squared plus d squared greater than or equal to x plus c plus d squared minus, wait, we're just literally getting what we had at the start, I swear. Yeah, we kind of are. I think, yeah, we're going around in circles. Um, yeah, because we're gonna get this. We're gonna get 2c squared plus 2d squared. It's gonna get to x plus c plus d. Okay, so this is not, but maybe this could be helpful. Um, okay. We can, no, no, without loss of generality, we can say x is less than 0, right? Because g of x takes on two different values. And without loss of generality, I haven't assumed anything special about x and y. So I can say x is less than 0, and that's fine. So I can say that this is less than 0. So if x is 0, this is true. Because you get c minus d all squared. Ah, okay. X plus c plus d squared. We want to get x is 0. Wait, x plus c plus d. Yeah. Okay, wait. X plus C plus D in terms of like A, B, M, N, X, Y is equal to B minus A plus X plus MA plus Y plus M plus 1B. Okay. Either we've made a mistake somewhere, or this is not the same as what we had before. It's one of the two. Okay, I think let's do this thing. Let's do C D thing from this. Let's say, wait, no, but the thing with C and D, that's just that's just writing it as that's just writing f of x rather than x plus some stuff. Yeah, this is. I can't figure out what to do. At least like P2 yesterday, I had a lot of ideas, and some of them ended up working, some of them didn't end up working. Here, like none of my ideas are giving me anything, so it's not very. It's quite demoralizing to be honest. Like, but I feel like there's nothing else you can really do other than the stuff I'm trying to. Okay, what are my ideas? My ideas are okay. So what do we have? We have because let's do like good things. Like, it is for like the John Chris and all. Let's do good things and like bad things. Okay, so good things. What have we done? We've shown that we showed this one thing at the start. That's quite good. And we wait. I swear there was something else. Oh yeah, yeah. We want to show that g of x is constant. Okay. So the good thing. So all of this, like, for the past 1.5 hours of thinking, this is what we have to show for it. There's one thing we found after like 2 minutes, and this thing that we want to show. Okay. And the bad thing, I wouldn't say bad things, but stuff that we want to do but haven't done, rather than bad things, the stuff we should aim. This rather than say bad, say like it's our aims for the next phase of trying to solve the problem. So like our aims are we want to get F increasing. We want to get F is increasing. We want to get that F. I swear there was nothing. Oh, the g of x constant thing, and that should probably be in here. So we haven't shown that, right? Yeah. Okay. So rather I'll put we guess the answer. Okay. So we got this thing after 2 minutes, and we guessed the answer. And our aims are this thing. We want to show g of x is constant. We want to show f is increasing. And that's about it, really. Yeah, okay, so, okay, that's not too much. Do you have any other ideas? Let's think of some other ideas. Yeah, I'll put in the good thing that we have f of x bigger than x. That's a good thing. Yeah, that is a good thing. Okay. Okay, well, it's all about the middle thing. It's all about the middle thing. Because, yeah, it's all about the middle. It's all about the middle term. It's about squeezing the middle term. That's what it's about. And we squeeze the middle term, and the left and the right term are close together. And that happens when x is close to f of y. Okay, wait. How about I plug x as f of y? Because like, yeah, I think because f of y is y plus g of plus 2g of x. And for large y, because g of x is a constant, right? It's constants are always going to be small, right? So if you have x to the n plus constant, eventually the constant is going to matter much. So yeah, so we have this this constant g of x or ng of x. So f of x is x plus 2g of x. And, or rather, sorry, f of y is x plus 2, is y plus 2g of y. And we're gonna get f3y as well, because we have to do f of x. So that's gonna be y plus 3g of y. And then, so we want to squeeze the middle thing. So we want to make the left thing and the right thing close together. And they're going to get relatively close together the more this constant term becomes meaningless. And it becomes more and more meaningless the bigger y is. So we're gonna do this, we're gonna plug x as f of y, and we're gonna make y very big. So okay, so we have the y, let's just write x, I don't want to write y. So x plus 2g of x squared plus f of x squared. F of x rather, let's call it x plus g of x squared over 2 greater than or equal to f of x, so it's f3, actually f3 of y, which we're calling f3x. So x plus 3g of x plus y, which we're calling x. Yeah, over 2 is greater than or equal to the square root of x times, not x, x plus 2g of x times f of y, which is x plus g of x, because we swapped. Yeah. And then if we make x very, very big, then relatively these three things can get relatively close together. So that should give us something nice. Again, we don't have anything concrete, we're just like, yeah. So it's 2x squared plus 6xg of x plus 5g of x squared greater than or equal to x, 2x plus 3g of x over 2 greater than or equal to the square root of x squared plus 3x g of x plus 2g of x squared. So we don't know g is constant. So yeah, but I think this is okay. Yeah, if we get g constant, we're done. Right? That's all we need to show. That's the whole problem actually. Yeah, that is actually the whole problem is to show that g is constant, given that recursion f n x equals x plus n g of x. That's the whole problem. And I feel like the only way to do that is by assuming it's two different values for two different x and y. Yeah. Okay, what if we assume it's increasing, is the problem easier? Does it really make our life that much easier? Yeah. Okay, let's say it's increasing. So whenever x is bigger than y, which x is bigger than f of y. So let's put x is bigger than y in that thing. What do we get? We get the square root of x squared plus f of y squared over 2 is less than x squared plus f of x squared over 2. And x is bigger than y. And yeah, I don't really feel like f increasing is that useful. Yeah, so all we're trying to show is that g is constant. Yeah, I feel like this is the whole problem. So, and I feel like the way to go about it is this. So to use this, you choose the fact that this is true for all n, and then assume that g is different for at two values. Yeah, okay, so yeah, yeah, this gives me flashbacks to yesterday from Assault B2. Like, yeah, I think that was a similar thing. We didn't get a lot of stuff for a very long time. And then we went on GeoGebra, and then we assumed some stuff is true, and then we solved the problem, and then we were able to go back and show that stuff is true. But here, there's only one thing that we need to show is true. Like, there's no series of things we need to show. I think there's just one thing, and it's this: the G is constant. I think the way to do it is to use this recursion in some way. And the only way to use it is to plug it in, and we did that, and then we didn't really get anything. Okay, let's do it again and look hard. I think that's what we should do. So yeah, so let's say this is x plus na and x plus nb and y plus nb. And let's say that this one is c and this is d. Yeah. And but isn't that just the same as plugging x and y in? Okay, yeah, yeah. Let's say that yeah, let's say we don't need to use n. Let's say f of x is x plus a and f of y is x plus b. Is y plus b. And these and a and b are different for some x and y. Okay, let's see what we get. So we have square root x squared plus y plus b squared over 2 greater than or equal to x plus a x plus y plus a over 2 greater than or equal to square root x times y plus b. And we want to show that this forces A equals B. Yeah, okay. So this one, what does this one tell us? This one tells us that, yeah, I've done it so many times, like greater than or equal to this one squared. So, and the other side gives us, so we got this big inequality. And then the other one gives us, I don't think this is going anywhere. Okay. Yeah, I feel the experience of solving problem 5, so far at least, has been very similar to my experience of solving problem 2. And problem 2, we ended up solving it in the last 5 to 10 minutes. And we have 2 hours left right now. But we did solve problem 4 much quicker than we got problem 1. Okay, what I haven't done, I've plugged x equals y. Why haven't I done that? Um, why haven't I done that? So let's do that. Wait, what? No, 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 we're fine, we're fine. Oh yeah, that's why I didn't do that. Yeah, it doesn't give you anything. Because then it's just AM, QM, GM. Yeah, with the, yeah. Okay, okay, which terms do I have repeated? We'll have this xy on the right side in both. I have this x squared plus y squared in both. 2xa switches sides, and yeah, okay, there's 2xa plus 2y switches sides. And more of it, like a squared plus 2, this whole thing switches sides. Okay, that means I can bound this thing from above and below. Yeah, but I doubt the things above and below are going to be equal, right? Yeah. But let's just see what we get, just to improve our understanding of the question, if nothing else. And for this one, we have we probably can make this a bit smaller. Oh, oh, fine. Yeah. Um, so is this bound for B going to be useful at all? Okay, so 2x minus y squared is greater than or equal to. I mean, we're comparing this and this. 4xb minus 4yb minus 2b squared divided by 2. Put out a factor of b, 2x minus 2y minus b. So if the x minus y is equal to b, we're not comparing a and b though. We're just comparing b is just g of something, right? Like this is all. I don't think this is that helpful. No, I have a lot of respect for people who can stay at full capacity for 4.5 hours straight. Like that takes a lot of work. It's not an easy thing to do. Oh, but like yeah. This is just this is just x minus y minus b all squared. It's equal to 0. Yeah. Oh yeah, yeah, fine. Yeah, so no point in this. Okay, we need to compare A and B. We need to compare A and B. Yeah, I don't have any ideas other than this. Oh, yeah. We need new ideas. Because ideas we're having aren't working. So, oh wait, because when I did that, I removed some of the question. Okay, at this point, we only really care about G. We only care about G. So, oh, I remember I said at the very start we could try rewriting stuff in terms of G. Okay, I mean, okay, is there anything else that I'm sort of trying, but have tried? F increasing, but like, as we discussed, I don't think that's going to be that useful. Like, we can't reuse the fact that F is increasing in any real way, given the condition we have. And the only reason we'd be using F increasing is to find out stuff about G rather than about F. So we only really care about G. Okay, so yeah, let's try rewriting something in terms of G. It could work. I mean, it doesn't work a lot, but like I have nothing better to try than this. Yeah, okay, let's write g of x is fx minus x, and so we have the square root of x squared plus g of y plus y squared over 2 is greater than or equal to g of x plus x plus y over 2, which is greater than or equal to the square root of x times g of y plus y. I mean, this one looks neater, so let's do this one and this one first. Uh, okay. Okay, so we can get rid of this 4 and make some -2. So I can make this g of x. Or I need two minuses for that, yeah. Let's see if I can write this thing as a square. Um, maybe like, okay, so we have xg of y here, xg of x here, yg of x here. Okay, it's very close to g of x plus x minus y all squared, which is g of x squared, g of x squared plus x squared plus y squared plus 2x g of x minus 2y g of x minus 2xy. Okay, so okay, so yeah, let's do this. So we have g of x plus x minus y squared is greater than or equal to 4x g of y minus 4y g of x. Okay, what would be even better than this? Well, okay, what about g of x minus x plus y squared? Would that be better? G of x squared plus y squared minus 2x g of x um minus 2x g of x plus 2y g of x minus 2xy. Yeah, so this would become, if I make this a minus and this a plus, this would become an x rather than y. Okay, so we'd have g of x minus x plus y squared is greater than or equal to 4x g of y minus g of x. I think this is really good. Because we have a g of y minus g of x. If this is 0, we're fine. But if it's not 0, then can we make this 0? Well, yeah, we can make that 0 by setting, oh no, but if you set y to something specific, you're losing generality. Okay, wait. Okay, what facts do we know about G? We know some stuff about G, right? Like, yes, we had something like G split. Um, we had something about G on one of these pages. Just a minute. Yeah, this thing. We had the G of X is G of X plus Ng of X. Yeah. And that comes from this thing. So we have the Fn of X is X plus Ng of X, and rewriting that gives us a g of x is g of x plus ng of x for all n. Okay, so this gives me more degrees of freedom, basically. That's what it does. So yeah, okay, so let's look at this thing. So g of x, what is it? Minus x plus y squared greater than or equal to 4x, g of x. Okay, I think we might be on something. Okay, and we have this thing. G of x is g of x plus n g of x. So I can shift x by ng of x. I can say this is um I can shift y by ng of y. So I have g of x minus x plus y plus ng of y squared greater than equal to 4x g of x minus g of y. Because we're not changing the value of g of y if we change y. So if we shift y by a multiple of g of y, we don't change g of y. I know it sounds complicated, but like g of y plus n g of y equals g of y. So that's what we're using here. And then can I make this thing zero? Somehow. Well, okay, we can move n to make this thing very, very small, right? So let's say this is zero. Okay, then and n can be any integer. I don't think it needs to be positive even. It can be negative. So it's x minus y minus g of x over g of y. Okay, and that's gonna make this very small. Okay, how about I shift x as well? If I shift x as well, then we're gonna get this 4x thing is gonna move as well, which isn't that nice. Yeah, we don't want that to happen. Wait, but do we care about that? If this x moves, if we can get this to be zero, we know that g of x is positive. So if we shift this by a positive thing, it's going to be positive. So if this is equal to zero, we have, yeah, we have positive times g of x minus g of y is less than zero. So we have, this needs to be less than zero for all x and y. But then that implies something's gone wrong because you can just swap x and y. So yeah, let's try doing that. Let's shift x by mg of x. So minus x minus mg of x plus y plus ng of y squared greater than or equal to like whatever. We don't care at this point. Okay, and we want to make this zero. So rearranging for n, this time we have x is x plus mg of x instead. Minus y minus g of x over g of y. And we want to make this an integer. I feel like this is what's going. I think we've got something. Like this is why g needs to be constant. Because I can make this square term here as small as I like. I can make this square as small as I like. At least I should be able to because of these shifts we have with x and y. I should be able to make this thing as small as I like. And this can't be, and this is going to stay roughly the same. Okay, we got to think. Oh, okay, wait. Okay, we need to be really careful. Okay, we're shifting x. Wait, if I can make the thing on the right get really big and the thing on the left get really small? then we win, right? Yeah, then we win. So let's do that. Okay. So we can make M really big. Make M really big, and we can kind of make N match it. Yeah, if N is in and around this value, if N, maybe not exactly this value, but like in and around this value, and make M massive, then we win, right? Because if N is in and around this value, this is going to be zero, or like very close to zero. Okay, but why? That implies that has to be zero to bring it back down. Fine, yeah. So we make this x plus mg of x term really big, and then we make the thing on the left really small. And in order for the inequality to hold, we need g of x minus g of y to be very, very small, but we need it to be arbitrarily small, so it has to be zero. Okay, I like this argument. We have to make it like rigorous. We need to formalize this chain of thought. Like this is a very good chain of thought. Um, at least it feels like a very good chain of thought. Like it might not end up working, but I think this one. I think this is the one that works. I think this is the one that works. Um, yeah, because we've got it. We've got it. We just need to like. Okay, we're not doing too bad for time. Okay. Um, yeah, this is like. I think with that. Okay, let's okay, what if n is I don't. Do we need the nearest integer? We can just take the floor, right? The floor, yeah. Um, we don't need the nearest integer because if you make m very big, it's not going to matter how small this is. It's just going to matter that it's very, very small. And this one is arbitrarily large. So the only way it comes back down is with this one being zero. Yeah. So if I take this is the floor of this, that makes the thing on the left very, very small. And then we make m arbitrarily large, and then n is a function of m. So as we make m arbitrarily large, n follows this thing. We move n. We should move m and we move n at the same time, and that makes this thing really small. But then this thing gets really big, so this thing has to be zero, and this one gets arbitrarily big. Yeah, but we need to bound this thing from because this might be small. This might be small, but as this goes up, this might go like down, up, down, up. It might stay small, but it might go. It might stay small, but it might get big enough to prevent this. Like it's not. We're not fully there yet. Okay, so the floor. Okay, the floor. So the. Oh no, this is g of y. So the largest integer less than or equal to this thing. Okay, so I can write x plus mg of x minus y minus g of x over g of y as n times times some integer w plus r, where r is between 0 and 1. Yeah. I feel like this is the sort of thing that is hard, but the sort of problem you probably need to get like a silver medal. Yeah. Wait, how does the floor function work again? Oh no, it's not NW. It's just, yeah. That's why I was confused because I'm like, why are we getting W? Because, yeah, fine. So it's just N plus R, and R is between 0 and 1. Wait, floor function. Yeah, this is how the floor function works, right? So it's X plus mg of X minus Y minus g of X, which is Ng of Y plus Rg of Y. So we we move yeah, so we move all this stuff to here, and we move this one here. So we're gonna get minus, so it's gonna become minus Rg of Y squared. Yeah, and R is between 0 and 1. So all I care about is the size of Rg of Y. So the size of Rg of Y, well, g of Y is positive, so it's equal to Rg of Y, which is less than g of Y. So this is less than, or, okay, yeah, we're done. This is less than equal to g of Y squared. Yeah, I think we're done. I think we're done. I think we're done. So g of Y needs to be constant. Oh, constant. But what if g of x? Yeah, no. What if the constant is 0? Because we did something illegal. Yeah, because in the case f of x equals x, g of y is 0 for all x. So we're not allowed to do this. We're not allowed to divide. We're not allowed to talk about the floor of a number that doesn't exist. Because this number doesn't exist if g of y is 0 for all y. Okay, this is like, okay, so wait, this is literally like this is literally IMO 2024 policy. It's the same problem. Okay, I think this calling it the same problem is pushing it a bit, but it's exactly the same thing. So if if g of y takes on two distinct values, two distinct, yeah, so g of y can't take on two non-zero distinct values. So okay, so g of x is um is 0 for all x, or it's 0 for some x, and it's some positive constant for all the other x. Okay, I think we can show that, or it's just the constant for all x. I think we can show that the middle case is not possible. So let's suppose. Okay, so let's suppose that g of x. Okay, I suppose f of x is x, and f of y is y plus b, and b isn't zero. Then we're gonna get x squared plus y plus b squared over 2 square rooted greater than equal to x plus y over 2 greater than equal to square root x y plus b. And I think this is going to force b equals 0. Uh, yeah, okay, let's square it. So x squared plus 2xy plus y squared. I've done this so many times in this problem. For y plus b. So we're going to get x minus y squared greater than equal to 4bx. And x is not equal to y. Um, but you might be able to partition the real numbers in such a way so that this is fine. Yeah, you could be able to partition the real numbers so that this is actually true. Yeah, because I'm tempted to say like put y really close to x. But what if the way you split the real numbers means that when y is close to x, then when y is close to x, then f of y is y. But when y is far from x, then f of y is y plus b. So this thing is actually fine. Okay, but then okay, let's look at the other one. So okay, so you would double the numerator of this one, and then yeah, and let's just expand all the stuff like x squared plus 2y squared plus 4by plus 2b squared greater than or equal to 2xy plus y squared. Get rid of this. So again, x minus y squared plus is greater than or equal to okay plus 2b squared plus 4by is greater than or equal to 0. This is sum of squares now, so you're fine. Because it's x minus y squared plus 2 b plus y squared. Ah, no, but it's not sum of squares. It's greater than or equal to 2y squared. Okay, so why does this force b equals, why do these two together force b equals 0? Okay, well we have that, okay, so b is less than equal to x minus y squared over 4x. Yeah, because x isn't 0, fine. But is greater than or equal to, okay, this one's a bit tricky. Greater than or equal to minus y plus the square root of y squared minus x minus y squared over 2. Or maybe it's over 4. Um, no, it's over 2. Because b is positive, right? Yeah. Well, this is like, It's virtually the same, it's a very similar experience to problem two, yes, like you get to the final step, and that's the hard bit. Imagine if if this takes me until like the last 5 minutes again. But yeah, we've got a lot of time. Okay, so what are our two conditions? Our two conditions are, let's write them in a nice way, not in like a weird, like quadratic formula thing. Um, for bx and then like um 2b plus y squared is greater than or equal to 2y squared minus x minus y squared. Okay, so this one implies, okay, so if f of x equals x for some x, oh, okay, I think I've got something. So if it means that if f of x equals x for some x, then then f of y has to be y um for all y so that the so the so that x minus y squared is strictly less than 4bx. Taking the square root of x minus y less than 2 root bx. So for all y greater than x minus 2 root bx. But also, but also, um, so if y is, okay, this is if x is bigger than y. Yes, if x is bigger than y, this one is true. But if y is bigger than x, then this one is true. So we have, if y is bigger than x, then this one is true. Okay, so for all y, so that the the distance between x and y is less than 2 root bx. But then like, but then, but then if I have f of x equals x for 1x, then I can say, okay, so for all, imagine like a line, and you have f of x equals x at one point, and then the rule says, okay, so for you have f of x is x at that point, and then for all x this much above that point, f of x also equals x. Then you can do the same argument from the top of that region. So like if x equals x, then for x in a certain region above x, fx also equals x, and then you can apply the same thing, and you can keep going up and up and up. So that just implies f of x is x for all x, and because you can do the same thing going downwards, right? So this actually implies fx equals x for all x. Yeah. Okay. So I think we did show that if f of x is x plus b for all x, we're fine. Okay. So yeah, so we're done. So we are done. F of x is x plus some non-negative constant b for all x. Okay, right, so we've got some time left for P3. Okay, let's write up P5. Let's write up P5. Yeah. Let's write up P5. Okay. So, okay. So what was our, okay. So the first thing we did, we just looked at this and was like, we want to squeeze the middle thing. So we plugged x as fy. So plug x equals fy gives that fy greater than or equal to f of y plus y over 2 greater than or equal to f of y. So, which implies f of just say x is minus f of x equals f of x minus x for x. Okay. So now we define g of x is f of x minus x. Okay, let's mark the thing as star. So star says that x f of x f2 of x is an arithmetic. Can you say a just arithmetic progression? Arithmetic progression, yeah. Well, like, yeah. So f n of x is x plus n g of x. So um so n equals 2 gives f of x, yeah, gives x plus 2g of x is f of x, which is f of x plus g of x, which is g of x plus g of x plus x plus g of x. So g of x is g of x plus g of x. But now sending x to g of x plus x gives g of x equals g of x plus g of x equals g of x plus g of x plus x, which is equal to g of x plus g of x, which is g of x plus 2g of x. So by induction, like g of x is g of x plus ng of x. I think this is fine. Just like I'll write it quickly. So like plug g of x plus ngx is g of x plus g of x. Mm, okay, x plus n minus 1 g of x plus g of x plus n minus 1 g of x. which is equal to g of x plus n minus 1 g of x equals g of x by IH. Just say that. Just give me a second. Okay. Now rewriting in terms of g gives g of x plus y over 2 greater than equal to this thing. Which I don't want to write the whole thing. What does it do? It gives that it gives that g of x minus x plus y squared is greater than or equal to 4x g of y minus g. Yeah. Okay, and now we apply the shift. Now we apply the same. So um now sub yes. Now sub x to x plus ng of x and y to y plus mg of y. We get uh g of x minus ng of x plus y plus mg of y is greater than or equal to 4x plus ng of x g of y minus g of x. I think we were kind of lucky with this. Like, yeah, I was trying stuff before plugging like g of x is a, g of y is b, and trying to do some stuff, but like again, I just rewrote in terms of g, and this thing came out on its own. So yeah. Okay, what was our plan? We want to make this thing 0, or like close to 0. So wait, I'm making this thing. What do we say we did? What do we put it as? We plugged it as the floor of yeah. This is crazy, right? I don't think I've ever done this on a problem before. Like something this random. Like the floor of x plus mg of x minus y minus g of x over g of y. Like yeah, crazy. Um, plug n as this. We got to turn it. Okay. So we have that what is it thing? X plus m g of x minus y minus g of x over g of y equals n plus r, where r is between 0 and 1. That's good. Okay. So x plus mg of x minus y minus g of x is ng of y plus rg of y. So g of x minus mg of x plus y plus ng of y is minus rg of y. So the thing squared is r squared g of y squared, which is less than g of y squared. So g of y squared is strictly greater than the what's it called, like x plus ng of 4x plus ng of x. Um, g of y minus g of x. Crazy. I think I think I might have peaked at geometry and algebra in these lifestyles. Like, have I solved a hard algebra question in this? Like, again, with respect to time, probably not. Yeah. I think like the hardest algebra question I've done was the I think like the 2022 P3 or something. It was some like easy P3 from some recent years. But like, that took me ages, and I did this in relatively quickly, I think. So I don't know how hard this is gonna be found. Like I feel like this solution is hard for me, but it wouldn't be hard for other people. That's what I feel. Like I feel this is something that's hard for me, but not hard for people. So I think this will have a normal solve rate for a medium problem. Yeah. Um, or maybe none. Who knows? So we have this thing, but we can make was it N or was it M? I thought it was M, right? Um we had mg of x. Yeah, it was ng of y and mg of x. I swapped them over. So it's ng of y, mg of x. Yeah, this one's m, this one's n. And then yeah, because I remembered the when we when we moved m when we changed when we changed this one, then this one changed as well. So it's gotta be m. It would yeah, crazy. But we can make m uh, as big as we want. We want, so we need g of y equals g of x, or g of y is 0, since then um, x plus m g of x minus y minus g of x over g of y is illegal because you're dividing by 0. Yeah. So we have um we have a subset of the positive reals A. We have two subsets of the positive reals, and which one is the one that joins them together? Yeah, I use this one for like two lines. It's probably this one. Yeah, is all of the positive real numbers. So, and for x and a, fx is x. For x and b, fx is x plus b for some b um in the non non-negative real numbers. Yeah, and like a could be the empty set. So yeah, I think this is fine. Okay, but uh, suppose f of x is x, f of y is y plus b. Oh wait, is that what we did, or did we do it the other way around? Oh, um, we did, yeah, we did this thing. So x plus y over 2 is greater than or equal to the square root. We just needed this one. Wait, we didn't really use. Wait, I just realized we didn't use the left bigger than the middle at all, other than in the first step. Like, everything else, it was all middle bigger than right. Yeah, yeah, okay. But we have this, so um, just yeah, so we have this thing, bx. Yeah, I don't want to write all that. Alright. Yeah. Wait, we are gonna check if this thing's correct. This is not correct, man. That's not good. Yeah, it is correct. Yeah. It's not very hard. Um, so the difference between y and x is greater than or equal to the square root of 2bx of 4bx. So so yeah. So f of y equals y for all y, so that this thing holds. But x is arbitrary in A. We could do the same for like x plus 4 root 4bx minus some like small number, giving and for the other side, and for x minus root 4bx plus epsilon for small epsilon, giving fx is x for all x. Okay, we need a third. Yeah. So so fx equals x for all x, or fx is x plus b for all x. F of x equals x plus b for all x for works. Yeah, we need to check that the thing works. Check is below. Okay, so we have to check two inequalities, not one. So do we have space? Yeah, I don't want to waste more paper, so I'm just gonna do it. Okay. Um, Yeah, so that's done. Okay, we are we are done with problem five. Okay. Yeah, and that's a wrap on my IMO 2026 live solve videos. I have to say, I really enjoyed this set of problems. My favorite paper other than this year was 2023, where I felt all the problems were really high quality, and yeah, there were also two geo problems. I feel like this year all the problems are equally very high quality, but personally, I prefer if one of the two harder problems are a bit approachable. Not like problem three last year, but I think it's nice to have one of the hard problems be at the difficulty of 2023 problem three, maybe even this year's problem two, so you get a good range of marks. In terms of how I did, I'd give myself 770, 770. I didn't really make any progress on either of the two hard questions, which is kind of annoying because the way boundaries work is you usually need some partials on the stuff you don't solve to reach the boundary. Had problem six been on geometry, this might have been a different story, but given how much I struggled on problem two, this is not guaranteed at all. Another reason I thoroughly enjoyed this set of problems is because it was very geo heavy. Like, I would say that two of the four problems that I was able to do were geometry, and only one problem on the paper was actually combi, the problem three, which I didn't attempt at all. I think this is a very welcome change from the usual, where we generally have even over half of the paper be combi in some form. Like IMO last year, problems one and six were the designated combi problems. And then you had problems four and five, which kind of had that type of feel to it as well. I thought that I should also share my thoughts on the problems in case anyone watching is interested to hear someone else's view. I felt that problem one might be found too hard for its place. I wouldn't say it's a hard problem, but problem one in the last few years has mainly been there to ensure that everyone is able to get some concrete progress on one of the problems, and I think that might not be the case this year. Looking back, problem two, while I found it quite hard, and I still think it's definitely hard for problem two, I wouldn't say it's unwelcomingly so, and that it's not uncommon to see medium problems of this difficulty for other topics, and there hasn't really been a geometry problem of this difficulty in any past paper. So something which I'd be happy to see in future years. I don't have much to say about problem four. Personally, I find it to be very easy, but the details aren't as simple as they seem when you go to write it down. Nevertheless, I think it's quite suitable for problem four. And yeah, this problem, problem five. Well, I'd say it's a good problem, but one that I would have completely demolished when I was in my prime. Like, I had the ability to rewrite the condition in terms of G after about 8 minutes. So if I had actually done this, I probably would have been done after just 25 minutes. So even though the problem ended up taking me much, much longer than this, I think that this is something that people at the IMO might find a bit easy for its position. Yeah, so I probably won't be posting on this channel for the foreseeable future as I get more busy with other things. But yeah, this has definitely been an enriching experience for me, and I ended up getting quite a lot more views than I was expecting to get. I hope that seeing how I approach these four problems was helpful for you guys, and yeah, take care.